So today we can start with the next set of instructions, that is the logical instructions. Logical instructions are the instructions using which we can perform AND operation, OR operation, NAND operation, XOR operation with the contents either that are present in any of the register or that is present in any memory location, or it is directly given in the instruction with the contents of the accumulator. Okay, or if we want to rotate the data either on the left side or the right side, then also we can use the logical instructions of 8085. Okay, so we can start with the first instruction, first logical instruction, that is ANAR. This instruction means logically, and this instruction means logically and the contents of accumulator and the contents of register. Okay, so this is the meaning of this instruction. So whatever contents we have in the register, that will be logically and with the contents of the accumulator. Now after this we can see the format. So whatever contents we have in the accumulator, that will be logically and with the contents of the accumulator. Okay, so this is the symbol of logical and these will be logically and with the contents of accumulator, and the result is again stored in the accumulator bank. Okay, now after the format, now we can see the addressing mode. So in this instruction you can see the name of the register is given on the destination side, as well as the name of the register is given on the source side also. So when we have a general purpose registers on both source as well as the destination side, then we can call the addressing mode of that instruction as a register addressing mode. So this instruction falls under the category of register addressing mode. Okay, next we have is the number of bytes. So this instruction is having 1 byte in the memory, because you can see again in this instruction no data is given explicitly and no address is given. So this is the only opcode, and opcode in 8085 will occupy 1 byte of memory. So this instruction will occupy 1 byte of memory. Now next we have is the flags affected. So in case of logical and in 8085, carry flag is always in the reset and auxiliary carry is always in the set condition, and along with that other flags like we have sign flag, we have zero flag, and we have parity flag. So these are modified according to the contents in accumulator. So whatever contents we have in the accumulator, so those contents will affect the value of sign flag, zero flag, and parity flag, but other these two values remains fixed. Whatever contents we have in the accumulator, so those contents won't affect these two values. These two values will be fixed for all the logical and operations in 8085, whether microprocessor is performing the logical and with the memory contents, or it with the data directly, or it with the data of the register. Okay, so these two values won't get affected by the contents of the accumulator after the execution of the instruction. Okay, so after the flags affected, now we can see the example. So before example, we can see the table. So see, we have a table where we have two inputs. So either the inputs are 0 0, either it is 0 1, either it is 1 0 or 1 1. So in case of AND operation, when we have 0 0 in the input side, then output is also equal to 0. And if we input any of the 0 we have, then also the output is 0. So here in this case we have one input as a 0, so that means output is also 0. Again in this case we have one of the input is 0, then output is 0. In case of AND operation, only the result is 1 when all the inputs are high. So in this fourth case, last case we have all the inputs are high, so that means in this case the output is 1, and in all the other cases the output is 0. Okay, now we can see the example. So suppose we have an instruction that is a n a b. Okay, and for the accumulator suppose we have contents 56h. Okay, and in the B register we have contents 82h. So we can see the example. Okay, so so in order to perform the logical AND operation, initially we have to convert these two numbers into binary form. So what will be the binary of 56? That is 0101, 6 is 0110. Here we have 82, that is 1000, and 2 is 0010. Now perform the logical AND operation. So this 0 and 0 is 0, 1 and 1 is 1, 1 and 0 is again 0, 0 and 0 is 0. 1 and 0 is 0, 0 and 0 is 0, again 0 and again 0. So you can see the output of this value is 0 to h. So after the execution of this instruction, again the result will be stored in accumulator. So that means after execution, what will be the value in accumulator? So after the execution, the value in accumulator will be 0 to h. Now we can see the flag values. So cy is always equal to 0. So that means the value of carry flag and auxiliary won't get affected by the contents of the accumulator. So cy is equal to 0. Auxiliary carry is equal to 1. Zero flag is equal to 0 because result is non-zero. Okay, so if the result is non-zero, that means zero flag is equal to 0. Next we can see the parity. So in this example or in this result you can see we have odd number of ones. So when in a program we have odd number of ones, then we can say the parity is equal to 0. Okay, and after that we have a sign flag. So sign flag value depends upon the value of most significant bit. So in this example you can see most significant bit is equal to 0. So when MSB is equal to 0, that means sign flag is equal to 0. So in this case, sign flag is also equal to 0. Okay, so this is the meaning of ANAR. Is it clear? Okay, so now we can see the next instruction, that is ANAM. So ANAM means logically and the contents of the accumulator with the contents of memory location with the contents of memory location that is pointed by HL pair. That is pointed by HL pair. So this instruction means whatever contents we have in the memory location that is pointed by the HL pair. So that those contents will be logically and with the contents of the accumulator, and the result will store in the accumulator again. Okay. For example, HL is having value 2050h, and at this memory location we have contents 22h. So this instruction means whatever contents we have in this memory location which is pointed by the HL pair will be logically and with the value of the accumulator, and the result is again stored in the accumulator. Okay, this is the meaning of this instruction. Now addressing mode. So when the M is given in the instruction, that means the addressing mode of that type of instruction is register indirect addressing mode, because here directly microprocessor is not getting the data from any register or from any memory location. Here initially microprocessor have to check the contents of HL pair, then from those contents it have to fetch the data that is stored in that particular memory location. So the process is indirect. Okay, so that means the addressing mode is register indirect addressing mode. Next is number of bytes. So again this instruction will occupy 1 byte of memory. flags affected. So all the instructions in 8085 that are the logical and instructions have same type of flags that are affected after the execution. So for A and A M also, these two values are fixed, that is 0 and 1, and other three flag values are modified according to the contents present in the register. Okay, now we can see the example. So we have a instruction, suppose A N A M. Okay, and here we have a accumulator and we have a HL value that is having value 2FFFH. Okay, so in the accumulator we have contents that are stored is 4A. Okay, so in the accumulator we have contents 4A stored, and at the memory location 2FFF we have contents that are stored is EFH. Okay, so we can see by applying the logical and operation between 4A and EFH. Okay, so see, 4A means 0, 1, 0, 0. A means 1, 0, 1, 0. Okay, now we have EF. EF means 1, 1, 1, 0. F means 1, 1, 1, 1. Apply logical and operation. 0 and 1 is 0. 1 and 1 is 1. 0 and 1 is 0. 1 and 1 is again 1. 0 and 0 is 0. 0 and 1 is 0. 1 and 1 is 1. 0 and 1 is 0. So after executing the contents present in the memory location and the accumulator, the result is 4AH. Okay, so this result is to be stored in the memory location, or this result is to be stored in the accumulator. So now the contents of the accumulator will be replaced with 4AH, and according to this result, zero parity and sign flag will be modified. So again you can see the result is non-zero, that means zero flag is equal to 0. In the result we have odd number of ones, so that means P is equal to 0, and in most significant bit we have 0 value, so that means sign flag is equal to 0, and other these two values are fixed for all the AND operations. Okay, so this is about ANAM. Now after this, third instruction we have that is related to the logical and is ANI data. Okay. So in this instruction, we have data present in the instruction. So this instruction means logically and the contents of the accumulator with the contents that are present in the instruction, with the contents present in the instruction. Okay, so this is the meaning of this instruction. So that means whatever contents we have present in the instruction, that will be logically and with the contents of the accumulator, and the result is again stored in the accumulator. So here we have a data in the format instead of the memory location. Okay, so this is the format of the instruction. Now we can see the addressing mode. So any of the instruction where the data is directly given, so those instructions are fall under the immediate addressing mode group. And moreover, second hint to identify the instruction is immediate, that if I is given in the instruction, that means the instruction is immediate type of instruction, because this instruction means immediately whatever contents we have in the instruction, that will be immediately logical and with the contents of the accumulator. So the addressing mode of this instruction is immediate addressing mode. Okay, next we have is the number of bytes. So this instruction will occupy 2 bytes of memory. Why? Because 1 byte for this 8-bit data and 1 byte for this opcode. So total this instruction will occupy 2 bytes of memory. Next we have flags affected. So flags affected remains same because this is again a logical and instruction. Now we can see the example. So suppose we have a instruction that is ANI0FH. So we have an instruction ANI0FH. So that means we have a data is 0FH, and in the accumulator suppose we have contents F7H. Okay, so in accumulator we have contents F7H and data we have in the instruction that is 0fh. So we can apply the logical and operation between these two contents. So F7 means 1 1 1 1 0 1 1 1. 0f means 0 0 0 0. F means 1 1 1 1. Now apply the logical and operation. So 1 and 1 is 1. Again 1 1 0 0 0 0 0. So when we can apply the logical and operation between F7 and 0f, then the result will be 07h. Okay, so this result will be stored in the accumulator again. So now the accumulator contents are 07h, and according to this, these two values are fixed. So these two values do not depend upon the value of the accumulator. Now we can see the value of these three flags. So 0 flag is equal to 0 because here the result is non-zero. Next we have is the parity flag. So you can see in the result we have odd number of ones. So when in the result we have odd number of ones, that means parity is equal to 0. Next we have the sign flag. So again you can see in the example, sign most significant bit is equal to 0. So that means sign flag is equal to 0. Okay. So this is about the logical and operation. Now you had observed one thing, that anything that we can logically add with 0 becomes 0. For example, we have contents 0 0 0 1 1 0 1 0. If we can if we can logically add these contents with 0, so what will be the result? So the result is 0 0 0 0 0 0 0 0. So that means anything that we can logically add with 0 becomes 0. Okay. Next we can see anything that we can logically 1 becomes same. So if we can apply logical 1 with this, then we can see the result. So result is 0 and 1 is 0, 1 and 1 is 1, again 0 1 1 0 0 0. So you can see anything that we can logically and anything that we can logically add with 1 becomes same. So these two values are same. This is same and this is same. So that means when we can logically add 0 with the contents, then that becomes 0. And anything that we can logically add with 1, that becomes same. Okay, so that is your AND instruction in 8085. Now we can come to next type of instruction, that is logical OR instructions. So for that we have ORI. Okay, so we can start with this instruction, that is ORI data. So this instruction means logically OR the contents of the accumulator with the contents that are present in the instruction immediately. Okay, now we can see the format. So here the symbol for OR operation is like this. Okay, so this instruction means whatever contents we have in the instruction that are immediately logical OR with the contents that are present in the accumulator, and the result will again store in the accumulator. Addressing mode is immediate addressing mode because data is given in the instruction and I is there in the opcode. Number of bytes, so again this instruction will occupy 1 byte of memory. Now flags affected. So in case of logical OR operation, carry flag and auxiliary flag will always in the reset state. Okay, reset means these two flag values will always be in the 0 state. Okay, so these two values are fixed for all the logical OR operation, while the value of sign flag, 0 flag and the parity flag, that will be modified according to the contents present in the accumulator after the execution of instruction. Okay, so that is the meaning, that is the under ORI data. So we can see the example, but before that we can see the table. So we have a OR instruction. So according to the OR, whenever we have inputs, both inputs are low, that means when we have both the inputs are 0, then the result is 0. Now, in next three cases, we can see when any of the input is 1, that means output is always equal to 1. So in second, third, and fourth cases, one of the input we have is 1. So if one of the input in case of OR operation is 1, then output is also 1. So this topic we already did in the 11th standard. Okay, that is the logical gates, that is OR and like this. Okay, so this is the table of logical. This is the table of OR. Now we can see the example. So suppose we have a instruction ORI 20H. Okay, so we have an instruction ORI, and here we have a data 20H. Okay, and in the accumulator we have contents 55H, and data on this instruction we have is 20H. So we can see what will be the output according to these contents in the accumulator and in the instruction. 55 means 0, 1, 0, 1, 0, 1, 0, 1. 20 means 0, 0, 1, 0, 0, 0, 0, 0. Now you can see 1 and 0 is 1. 0 and 0 is 0, 1 and 0 is 1, 0 and 0 is 0, 1 and 0 is 1, 1 and 0 is 1, 1 and 0 is 1, and 0 and 0 is 0. So you can see what will be the result after the execution of this instruction is 75H. This is 7 and this is 5. So this value will be updated in the accumulator after the execution of instruction ORI data. Now we can see the value of carry and auxiliary, that remains same, means these two values become 0 always. 0 flag is 0 because the result is non-zero. Next we have is the parity flag. So in the result we have 1, 2, 3, 4, 5, means we have odd number of ones. So in the result we have odd number of ones, that means parity is also equal to 0. Next we have is the sign flag. So here you can see most significant bit is equal to 0. So that means sign flag is also equal to 0. Okay. So this is about ORI data. Now, next instruction that we can see is ORA register. ORAR. So this instruction means logically OR the contents of the accumulator with the contents present in the register. Okay, so this is the meaning of instruction ORAR. What will be the format of the instruction? Here instead of data we have the contents present in the register pair, so that we can denote it like this. So the contents of the register will be logically ORed with the contents of the accumulator, and the result is stored in the accumulator again. Okay, now the addressing mode. So again in this instruction you can see both the source as well as the destination are general purpose register. Here we have the register like B, C, D, E, H and L, and here we have a register A. So A is also a general purpose register. So that means the addressing mode of this instruction is register addressing mode. Okay, next we have number of bytes. So this instruction will occupy only 1 byte of memory because explicitly no data and address is given. Only opcode is there, and opcode will occupy only 1 byte of memory. Flags affected remains same for all the OR instructions. Now we can see the example. So suppose we have an instruction that is ORAB. Okay, so this we have an instruction where in the B register we have contents B5H. Okay, in the B register we have contents B5H, and in the accumulator we have contents A to H. Okay, so now we can apply the logical OR operation between A2 and B5. So A2 means 1 0 1 0 0 0 1 0. B5 means 1 0 1 1. 5 is 0 1 0 1. Now see what will be the logical OR result. 0 and 1 is 1, 1 and 0 is 1, 0 and 1 is again 1, 0 and 0 is 0, 0 and 1 is 1, 1 and 1 is 1, 0 and 1. So what will be the result? The result after the execution is this is B and this is 7. So after the execution, the result in the accumulator will be updated with the value B7H. Okay, these two values remains fixed for all the OR instructions. 0 flag. This is also equal to 0 because result is B7, that is non-zero result. Parity is, now you can see in the result we have 1, 2, 3, 4, 5, 6. We have 6 ones. So we have even number of ones in the result. So that means parity is equal to 1. Next we have the sign flag. So most significant bit in this example is 1. So that means sign flag is also equal to 1 according to this instruction, that is ORAB. Okay, so this is about ORAR. Now next instruction that we can see is, if you have any doubt then you can ask in between. Okay, next instruction we have is ORAM. This instruction means logically or the contents of the accumulator with the contents of the memory location, with the contents of the memory location that will be, or that is pointed by HL pair. So this is the meaning of instruction ORAM. So whatever contents we have in the memory location, that will be pointed by HL pair. So those contents will be logically odd with the contents of the accumulator, and the result is again stored in the accumulator. So the format of this instruction is like this. Okay, so whatever contents we have in the HL, that will be logically add with the contents of accumulator. Now we can see the addressing mode. So again here M is given, that means indirectly microprocessor is getting the data which is being logically odd with the contents of accumulator. So the addressing mode of this instruction is register indirect addressing mode. Next we have number of bytes. So again this instruction is of 1 byte. Flags affected remains same. Now after this we can see the example. Okay, so we have an instruction ORAM. In the accumulator, suppose we have contents 55H. Okay, in the accumulator we have contents 55H, and we have a memory location that is pointed by the HL pair is D015H. Okay, and at this memory location D015H we have contents that is AAH. So this instruction means whatever contents we have at this memory location, that will be logically and with the contents of the accumulator. Okay, so see the result. 55 means 0 1 0 1 0 1 0 1 0 1. AA means 1 0 1 0 1 0 1 0. Okay, now see, 1 and 0 is 1, 0 and 1 is 1, 1 and 0 is 1, 0 and 1 is again 1, 1 and 0 1, 0 and 1 1, again 1, again 1. So what will be the output after the execution of this instruction? This is F and this is also F. So after the execution the result is FFH, and this result is being updated in the accumulator also. After the execution these two values remains fixed. 0 flag is equal to 0 because result is FFH, that is non-zero result. In the result we have even number of ones, that is 1 2 3 4 5 6 7 8. So 8 is even number, so parity is also equal to 1. Next we have the sign flag. So MSB is equal to 1, that means sign flag is also equal to 1. So you can see in this case this is most significant bit and this is least significant bit. So most significant bit is high, that means sign flag is equal to high. Okay, so that is the meaning of instruction. That is the meaning of instruction ORAM. Now, you can see anything that we can add with the contents, that becomes always same. For example, we have data 0 1 0 1 0 1 0 1 0 0 0 0 0 0 0 0. So it becomes this only. So that means anything that we can logically add, anything that we can logically add with zero contents, that becomes same. Okay, that means these two values remains same. Okay, next, anything that we can logically add with 1, that becomes 1. See, you can see in the result we have 1 1 1 1 1 1 1 1. So anything that we can logically add with the contents, that becomes same, and anything that we can logically add with 1, that becomes 1. Okay, so that is in case of OR instruction in 8085. After this we can start with next instruction, that is XOR instructions. So XOR instructions are XRAM. So XOR instructions are also known as the exclusive OR, and OR instructions are known as the inclusive OR. Okay, so this is exclusive OR. Now we can start with this instruction only, that is XRAM. This instruction means logically XOR the contents of the accumulator with the contents of the memory location that is pointed by the HL pair. Okay. Now we can see the format. So the format of the instruction is, here we have a symbol of XOR. So we can put the plus, and that plus is enclosed by circle. Or if you are not going to write this symbol, then directly you can write XOR also. Okay, XOR you can also write in between A and HL. Now, the addressing mode. So again, M is given in the instruction. That means the addressing mode of this instruction is register indirect addressing mode. This instruction is 1 byte instruction because this is the output which can occupy 1 byte of memory. If in any of the instruction explicitly data or the address is given, then that instruction is either 2 byte instruction or either it is 3 byte of instruction. But if explicitly no data or address is given, that means that instruction is only 1 byte instruction. Now next we have is the flags affected. So students, in case of OR as well as in case of XOR, the flags affected remains same. Okay, so in case of OR, these set of flags are in the reset condition. Same in case of XOR, carry flag and auxiliary carry remains 0. That means these remains in the reset condition, while sign 0 and parity are modified according to the result or according to the contents present in the accumulator. So flags affected remains same for all the OR instructions as well as for all the XOR instructions. Now we can come to the example part. So before that we can see the table. So in case of XOR, when we have same inputs, then output is always equal to 0. So in this first and last case, you can see we have same inputs, that is 0 0 and we have 1 1. So when we have same inputs, then the output is always equal to 0. And when we have different inputs, that means output is 1. So in this case, you can see 0 and 1, 1 and 0. So output is 1 and 1. So that we can find with the help of formula A B bar plus A bar B. So that is the formula to calculate the values or the output of the XOR gate. Okay, so वो सब हमने last year किया है. Now we can start with the example part. So we have an instruction that is XRAM. Okay, so this instruction we have where accumulator is having contents A5X. Suppose accumulator is having contents A5X. HL is having address 2050H, and at this address we have some different contents. So at memory location 2050 we have data that is 50H. Okay, so that means now microprocessor can apply the logical XOR operation between the contents of accumulator and the contents of this memory location, that is 50. Okay, so now we can see the output according to these two values. So first value we have A5. So 10100101. Next we have 50. So 50 is 01010000. Now see the result. Okay, 1 and 0 is 1, 0 and 0 is 0, 1 and 0 is again 1, 0 and 0 is 0. 1 and 0 is 1, 1 and 0 is 1, 1 and 0 is again 1, 1 and 0 is again 1. So according to this, what will be the value? This is F and this is 5. So after executing the logical OR operation, XOR operation, the output is F5H. So this value is updated in the accumulator after the execution. These two flags remains same. That means these two flags won't get affected by the contents of the accumulator. So this become 0 only. Now we have 0 flag. So 0 flag is equal to 0 because result is non-zero. That means here in this example we have a result that is F5H. Parity is equal to 1. Parity here you can see 1, 2, 3, 4, 5, 6. So we have even number of ones in the result. So that means parity is equal to 1. Next we have sign flag. So here in this result you can see a more significant bit is equal to 1. So when MSB is equal to 1, that means sign flag is equal to 1. Okay, so this is about XRAM. Next we can see XRAR. So this instruction means logically XOR the contents of the accumulator with the contents of the register. Okay, so whatever contents we have in the register, that will be logically XOR with the contents of the accumulator, and the result is again stored in the accumulator. So here we have, instead of HL we have a R register, and the content of register will be logically XORed with the contents of accumulator, and the result is again stored in the accumulator. Okay, now we can see the addressing mode. So again in this instruction, both the source as well as the destination are general purpose register. So that means the addressing mode of this type of instruction is register addressing mode. Next we have number of bytes. So this instruction will occupy only 1 byte of memory, because again in this instruction you can see no explicitly data and address is written. Next, flags affected remains same for XOR instruction. Now we can see the example. So we have an instruction, suppose XRAE. Okay, so this instruction we have okay, XRAE, and in the accumulator suppose we have contents 77H, and in E register we have, in accumulator we have contents 77H, and in E register we have contents suppose 06H. Okay, so now we can see the output according to these two values. So 77 means 0111 0111. 06 means 00000110. Now see the result. 1 and 0 is 1, 1 and 1 is 1, 1 1 0 0 0 0. 1 1 1 0. So what will be the output? The output is 71H. So after applying the logical XOR operation between 77 and 06, the value becomes 71H. So this value will be updated in the accumulator. So accumulator contents are now after the execution are 71H. Now see the value of flag register. So these two values remains fixed. 0 flag is equal to 0 because result is 71. Okay. Next we have, after 0 flag, next we have is the parity. So in the result we have 1, 2, 3 and 4. Even number of ones. So that means parity is equal to 1. Next we have sign flag. So most significant bit is equal to 0. So if MSB is equal to 0, that means sign flag is equal to 0. Okay, so this is XRAR. Now we are left with only one instruction, that is XRI data. XRI data. So this instruction means logically XOR the contents of the accumulator with the contents present in the instruction. So that is the meaning of instruction, that is XRI data. So wherever or whenever I is given in the instruction, that means that instruction is a immediate type of instruction where always data is given, whether it is a 8-bit data or it is a 16-bit data. Like we have a instruction LXI. So I is given, that means some data is given. So in LXI 16-bit data is given. In all the other instructions 8-bit data is given. Okay, so here instead of R we have a data. So this instruction means logically XOR the contents present in the instruction with the contents of the accumulator, and the result is stored in the accumulator again. Okay, addressing mode. So again this instruction comes under the immediate addressing mode because data is directly given in the instruction. So this instruction is immediate type of instruction. Next is number of bytes. So 1 byte is used by this 8-bit data and 1 byte is used by this opcode. So this instruction can occupy 2 bytes of memory. Flags affected remains same. Next, we can see the example. So we have a instruction that is XRI data. So here data we can take that is 2FH. Okay. So we have a data in the instruction that is 2FH, and in the accumulator we have contents, suppose 75H. So now we can apply the XOR operation between 75 and 2FH. So 75 means 0, 1, 1, 1. 5 means 0, 1, 0, 1. 2F is 0, 0, 1, 0. F is 1, 1, 1, 1. Now apply the logical XOR operation. So 1 and 1 is 0, 0 and 1 is 1. 1 and 1 is again 0, 0 and 1 is 1. 1 and 0 is 1. 1 and 1 is 0, 1 and 0 is 1, 0 and 0 is 0. So you can see after the execution of this instruction, this is 5, this is A. So after the execution, now the contents in the accumulator will be 5AH. Carry flag and auxiliary carry remains 0. 0 flag is equal to 0 because result is 5AH, that is a non-zero result. Parity is equal to 1 because we have even number of ones in the result. We have 1, 2, 3 and 4. 4 ones in the result. Next we have the sign flag. So here in the result, most significant bit is equal to 0. That means sign flag is equal to 0. Okay. So this is about the logical XOR operation. Okay. So next instructions, that is the instruction related to XOR operation, the instructions that are related to the complement of data, that we can study in the next lecture. Okay. So if you have any doubt in these instructions, then you can ask, otherwise we can close the session. Okay, no doubt, then we can end the session. Okay.